In this video, I'm going to talk about unusual values in the context of when we look at the scatter plot at the beginning of the process of building a linear model. So you may recall that when we get our data and we put it into a scatter plot, we want to confirm that we have quantitative data or variables. We want it to be straight enough, so we make an observation about the form and the direction and the strength of the association between the two variables. But then the question becomes, well, what about unusual values? Do we have any? And what we want to do is we want to point out if we have outliers, and then we want to analyze them a little bit. We want to know, do they have leverage? And probably more importantly, are they influencing the model in some way? Also, gaps are something that we should be concerned about, and groups. So what I'm going to do in this video is try to go through these a little bit quickly, if possible, just to kind of give an outline of what you should be concerned about. But in this process, if we can't say, we may or may not be able to create a model depending on the situation here. If we have certain outliers that have influence and that influence is not good, then we may not be able to proceed. Same with gaps or clusters. Okay, so the way I'm going to do this is I'm going to use some examples with my Fathom tool. So here I have some data. I've already put a line through the data to kind of help us sort of envision what's going on. So I have some data points here, and the mean is in X is 5.29, so almost 5.3. Okay, so as you can see, if you looked at this data, we would say there's no apparent outliers. But what if we took this point and we moved it way up here, like that? Well, now you should say that sorry, this happens a little bit, but you should say that it is an outlier. Okay, now what we want to do is, the question is, does it have leverage? So we can kind of estimate that the mean is 5.29, and I've tried to draw it so that it's right on the mean. And so as you notice, as I pulled up, so in the X data, you could really see, I remember the Y data, let's just do that real quick. If I take the Y data and do a scatter plot, you can kind of see it's definitely an outlier. This doesn't help me. Let's see if I can do it this way. Box plot. Well, the box plot doesn't show it as an outlier. That's interesting. Wonder if I move it just a little bit more. Sorry, I'm having a little problem with my tool. There we go. Now it's an outlier. Okay? So anyway, it shows up better if we use the a histogram or a dot plot. You can really see it in the Y direction. Okay, in the X direction, it doesn't show up as an outlier. That's because it's so close to the mean. So the bottom line here is that you would probably say this point has no influence on the model, so it's okay to proceed, because the model really hasn't changed. Remember, a point of influence, if we select it, and I think I can delete it, if it goes away, the model didn't really change all that much, just changed a little bit. So this case, we're not too concerned because it doesn't have influence. But now if I take this point and let me bring it back down to where it was. Now let's go away from the mean. So now it's a long ways away from the mean. The mean is now 6, so 13, so it's about 7 units away. And you can see what it's done. It's pulled the line down. That's because it has leverage and because it has influence. Notice the test for influence is if you delete the point, what happens to the line? So let's just do that. If we delete the point, bam, look at the line changes dramatically. So if you have a situation like this, where you're looking at a scatter plot and you're probably looking at it without the line through, so you would see it this way, then you would need to say, okay, there's an outlier, and because it's not consistent with the data, the rest of the data, and because it's a long ways away from the mean, it has leverage and influence. Therefore, this is altering the model in such a dramatic way that it probably doesn't make sense to proceed. Maybe we need to go investigate what happened here. Is it a typo? Did somebody make a mistake? Did the equipment fail when we were trying to measure the point? Or is it really an actual value? Okay, so that's an example. Now we probably have the same thing if the point was way over here. Let's put the line back. There's the least squares line. If I remove the point, the line changes dramatically. Okay, so again, it's because it has leverage. The further away it goes from the x mean, the more leverage it has. Okay, so now let's just do one more that's kind of fun to do. What if you get a point right here, way out there? Let's see, what's our data look like? It looks like in x we have an outlier, and I bet if we do y, let me just drag over the y data, even the y data, so it's an outlier in both x and y. So it's a long ways away. Okay, so the question is, though, is if you're looking at the scatter plot, can we proceed? So let's do this. Let's put a line through. Let's put the least squares line through. And now let's delete the point. Well, the line didn't change all that much, did it? It changed a little bit, but it didn't change a lot. R squared is still 0.95. So it's still a pretty good model. R squared was 9.7 when the point is in. Okay, so you can kind of see that in this case you would want to point out the outlier, say it exists, but even though it has leverage, it doesn't have influence because it's so consistent with the rest of the data. So you can leave it in. These outliers, when I drag it down, look what happens to R. R gets much smaller because I'm introducing all kinds of problems or all kinds of residuals. Okay, so that's a quick discussion about leverage and outliers. Now let's look at another situation. Let's look at gaps. You may recall that when we did the pumpkin activity, I purchased a bunch of small pumpkins from one store, and then I purchased some slightly bigger pumpkins from another store, and I actually thought when I was buying them that they were pretty close, and it would have smoothed everything out and it would have looked real consistent. But when we actually weighed the pumpkins, it turned out that we had a big gap right in the middle. Now we proceeded at that time to create a model, but the truth is we don't have any information right here. And so you should point this out if you have a gap, so you can see the gap much easier in X, but you can also see it in Y just a little bit too. So you should point this out when you're looking at the scatter plot. And then you should ask yourself, does it make sense to do predictions in this area? Probably not. This is a unique situation where you're extrapolating. It could be, probably with the pumpkins, if I would have got more pumpkins, that there was some kind of curvature that we didn't see because we had two groups. And if we would have if we would have filled in these, we would have had some curvature, which you can much easier see with the residual plot. Let me bring up the residual plot. If you bring up the residual plot, stretch it out, you can kind of see that we go down and then we come back up. So there might be some curvature in the data. So the point here is that if you see a gap, you want to point it out and then assess what makes sense. What should we do if we have a gap in the data? Possibly, like somebody suggested in this case, maybe make two models. Make a model through this data and make a model through this data. Something like that. Okay, so that's gaps. Now let's talk about, let's just use this data. Let's talk about clusters. Let me pull the data in like this. So let's say we start with some pretty decent, pretty decent data. But then what happens is that we have, let's have a point, let's put it right about where the mean is. We have some data points. Up here, like this. So in the X data, it looks, maybe it's even, if we had more data, we would say it's unimodal and symmetric. But in the Y data, look, we have kind of like a little cluster. Let's move this point over here like that. So we have the beginnings of a looks like a nice distribution of data right here. But then we have this other little cluster with a little tiny gap, but we have a cluster. And then if you look at the scatter plot, you can actually see it up here. So sometimes when you do experiments and collect data, you're not even aware that there's subgroups within groups. But in this case, you can see there is a group, and you should point it out. It's maybe only visible in the histogram of the Y data, but you can kind of see it on the scatter plot. And so again, the question is, well, what impact does it have? So the way I've drawn it, you can kind of see that this particular cluster is pulling the line up a little bit. If we put the squares in, where are they? Show squares. You can see we have a lot of residuals, a lot of squares. And these are certainly adding. I don't quite know where the mean is. So it's a little bit problematic. And so we may not want to move forward with a model. That's the bottom line. Let me take those squares off. If we draw the line and take the squares off, we can see that R is 0.29. So it's not a very good model. It's not explaining that much of the variability in Y, and it's probably because of these subgroups. If that subgroup wasn't there, we pulled them back in, they were closer, then all of a sudden R gets high, and so now we have a good model. Okay, so that's some examples. You could have groups off this way. In this case, you can kind of see they're dramatically altering the model because they're way over here, away from the mean. You can see some curvature in this case, which would also should show up nicely in the residual plot. So the residual plot also shows some curvature. Okay, so bottom line, when you're looking at a scatter plot, don't just quickly say, oh, no unusual values. Actually think through it. And when we started the chapter, we skipped over this because I wanted to make sure you knew how to do all the steps. But now that we're getting more familiar with building a linear model, we need to take a closer look at these outliers if they exist. So ask, do they have leverage? And more importantly, are they influential points? Also check for gaps and groups. Okay, good luck.